Grade 12 learners, welcome to the Scienceless channel. Question 2 of your paper tomorrow will begin with organic chemistry, particularly introduction to organic chemistry. This question usually they test the basics of organic chemistry. Now we'll begin our question. As usual, you would know that when we do any question in physical sciences, we have or we use the academic constitution that uses the mnemonic that says, I can solve this problem. These are a set of rules that we use when solving our problems. We'll start with the I. The I involves interpreting the problem, right? We read the problem and check the information that we're given. Right, I'll begin by doing that. So the problem reads as follows. They say here letters A to F. So we have letters A to F. In the table below, represent 5 hydrocarbons and 1 member of the alcohol homologous series. So here we are told that we have 5 hydrocarbons. Remember that the hydrocarbons are really compounds that contain only carbon and hydrogen. And I can see here that this is a hydrocarbon, but now this one here is not necessarily hydrocarbon because it has an hydroxide here and alcohol attached to it, right? So it's a member of the homologous series of alcohol. Then here I can see also that I'm actually having hydrocarbons because here there is no any functional group that is not hydrogen and carbon. And this one you can clearly see as well that it only consists of hydrogen and carbon. This one is an interesting one. If you look at this part here, it consists of hydrogen and carbon, right? And there are no any other functional groups. But now when you look at here, we have H2O, we have water. Now remember, this is not attached. This is not a bond. It's a plus there. This means either this is a reactant or it is a product. If it's a reactant, we're adding water in this reaction to form something else. But if it's a product, it means this, we then form this compound here, the hydrocarbon here, and we release water. Usually it will be released as a gas, right? So this is still a hydrocarbon, just that it's either adding water in the reaction or releasing water in the reaction, depending on whether this is a product or a reactant. And definitely this, you can see that it's a hydrocarbon. There is a chain of carbon that consists or it is bonded to hydrogen, right? That is my interpretation. You know, in this question, do not go further by naming these things when you want to interpret them, because there's a lot of other interpretations that I can do here. But I'll stop here because now the questions will be asking specifics of each molecule here. So if you want to analyze further, you'll waste time. Just have an understanding of what they've given you in a statement linking to this information, right? Now, because I'm done interpreting this question, I'll focus my attention on classifying this problem. Classification involves linking this particular problem to the theory, concepts, laws that we know from our topic of organic chemistry, right? This I can see clearly that, you know, it's a basic understanding of hydrocarbons. I need to know my functional groups. I need to know my different organic molecules, right? So I'm expecting here to be asked questions around those, defining some of the terms that we know in our basic understanding of organic chemistry, right? And obviously here we don't do much of calculations, so there won't be any formulas that I use. At this stage, I'm ready to answer the question. So I'm done with classifying the problem. Then I'm ready to answer the question. We'll go and answer our questions. Now we'll go to our questions now to answer our questions. Now the first question says to us, define the term hydrocarbon. Oftentimes the question paper also guides you. If they start telling you about terms there, you are most likely going to be asked to define them, or maybe to draw organic compounds of those of those terms that are used in them. So the first part of this question would be us going to define this. So this is question 2. Right? I think chemistry is fun. We often say chemistry is fun. It is fluorine, uranium, and nitrogen, right? Because sometimes it's not hectic as compared to physics. You don't do calculations or a lot of things. I mean, this answer here, it's 3 marks because this involves you going to study and memorizing your terms, and you simply just state your terms. This reminds me more of biology, just memorizing and getting in there, giving the answers. So here, I know from my studying, right, that hydrocarbon is a group of organic compounds that contain only hydrogen and carbon atoms. Right, as simple as that. 3 marks, guys. Right, the second question says between E and F. So E and F is these molecules here, the very last ones, right? Which hydrocarbon is saturated, right? Now, remember that a saturated hydrocarbon, right, will consist of only single bonds, right? An unsaturated hydrocarbon will start having double and triple bonds. Now, this is a simple one to answer. You can see here we have a double bond, so this has to be an unsaturated. This has to be an unsaturated hydrocarbon. And definitely this is a saturated hydrocarbon because we only have single bonds in there. Right, so our answer here is F. One thing that's very interesting is that after answering our questions, we have to navigate the answer, meaning we have to see if our answer makes sense, right? Oftentimes, this is a powerful technique when we do calculations, but here, because we are stating statements or answering, giving motivations, right? It's not that hectic. The only thing that you can do is that when you want to navigate your answer to check if your answer makes sense, right, or if there's no errors, is that after writing your answer, you can reread your statement to see if maybe your spelling is correct, to see if maybe you didn't omit anything, and your sentences are structured really well, right? You can, and if it's a question like this, you can just double check if you chose the correct one. Maybe you didn't choose D versus C. Such mistakes occur, right? So this allows you to maximize on taking those marks because you check your answers before you move to the next question, right? So clearly we can see here that we are doing well so far. Then we'll move to question 2.3. They say here, define the term homologous series, right? Again, here this involves us having studied and memorized our work, right? A homologous series, we know that is a series, right? Is a list, when I say series, right, of related chemical compounds that have the same functional group. And the same general formula, right? So this is a list of those compounds, right? Now there are many ways of defining this, because here is just a matter of English and using different words. One of the other, any of the ways that you have studied in your textbook will be allowed and will guarantee you a full mark. One of the ways would be that you can say is a series of organic molecules in which each molecule differs from the next by the same group of atoms, right? That will be also acceptable. Now, just to see here, all these questions, they are worth 1 mark. So to give that statement is 1 mark. I mean, really, there isn't much that you're doing here. It should take you a minute to answer these questions, right? Now we'll move along with our questions here. We're going to question 2.2. They say here, write down the IUPAC name of the compounds here, right? Now I can see also here that the numbering is also incorrect. If you get to a question paper and the numbering is incorrect, please keep that incorrect numbering, continue with it to allow the marker to know where you are, right? Because such mistakes can happen when the examiners do these question papers, right? So here we are on 2.4. So we'll say this is a 2.4. This is a 2.4, but we also acknowledge here that we have an error in terms of the numbering, so we'll keep it as it is to say this is a 2.3.1. Now they say here we need an IUPAC name. Remember that when we name our organic compounds, we use a system, right, a nomenclature that help us to classify and name compounds, right? That nomenclature assists us, so the classification system, it assists us so that we all can have the same common name. Even if you are in a different country or a different world, when we have the same compound and we are naming it, we can have the same name. That's why we have those set of rules that we follow when we name these compounds. Now we'll go to B and see how we can name that, right? Now when we look at this carbon B here, it is best to name these carbons when they are actually in a structural formula rather than a condensed structural formula like this, right? So I'll turn this into a structural formula so that I can name it with ease, right? So now I'm going to draw this to say I have 1, 2, 3 carbons, right? So I have this carbon here, and that carbon there. Now this carbon here at the end is attached to 3 hydrogens. It's an alkyl group, giving me methyl there, right? And then I also have this one attached to hydrogen and hydrogen. This is also attached to hydrogen and also this attached to hydrogen. And at the end there, we also have an OH, an alcohol group. Obviously, remember that carbon always has to have 4 bonds. That's why here we'll then add that hydroxide, right? Our alcohol. Right, the first thing that we do with naming is that we identify the functional group, right? So we can see that the functional group here is alcohol, right? So this means that, and we only have single bonds here, there's no double bonds, right? This means the base name of our compound will end with the anol, right? To say we have single bonds and we have a functional group alcohol there. That's the first thing that we do. Right. The second do that we do is that we identify the longest continuous carbon chain. Right. Now, if we look at this molecule, is a very simple molecule because our carbon chains are only here. We don't have any branched chain. Right. So this will be the longest continuous carbon chain that we have. Right. Now we then go into allocate a prefix to this carbon chain to say they are 1, 2, 3 carbons. This means this is a prop, right? Because we know that our prefix prop means 3, right? So this means here our the prefix comes in front of this anol, right? Our prefix here will be a prop. Then our base name now will be a propanol, right? That is our base name. We call this a base name of this organic compound, right? Now here we don't have branch chains or anything like that, but we only have an alcohol. So now we're going to use this alcohol, right, to count our carbons, right? When we count our carbons, because we need to count our longest chain here to arrange our carbons in terms of counting them, right? When we count our carbons, we count them from the side that is closest to the functional group, right? So the side closest to the functional group is this carbon here. It is close to this functional group. That means I'll start counting from the left going to the right. This is going to be the first carbon, second carbon, and third carbon, right? Now we're doing the counting because we want to identify the position of our functional groups, or even branched chain if we have branched chains in our molecule, right? So in this case we only have the functional group. So this means when I identify this, I'll say my functional group, right, the propanol, is actually sitting on the first carbon, right? So this will be one. So this means it will have one propyl, right? We'll have one propanol, right? This means that on our first carbon we have our functional group OH, right? So the name of this thing will be one propanol. So here we'll have one propanol. Now let's name our second compound. They say here we name D. So D is this one here. Now in naming D, we do the same rules again, right? The first thing is to identify our functional group. We can see here that our functional group really is an alkane. We have an alkane here because we all have single bonds and there's no any other functional groups here, right? So this would mean that our base name will end with an A and E, right? And then the second thing, we identify the longest chain. Now, in identifying the longest chain, we can see that if I count here 1, 2, 3, I have 3 carbons. If I count here 1, 2, 3, I have 3 carbons, right? If I count from this side 1, 2, 3, I have 3 carbons as well. And of course, going from that side is also 3 carbons. 1, 2, 3 is 3 carbons, right? So whether we count like this or we count like that, or even if we count like that, we have 3 carbons. So in this specific one, it doesn't matter from which side we count because we have the same number of carbons, right? So to keep it simple, I'll use this as my continuous long chain. I'll use this as my continuous chain. I want you to use this as the continuous chain, the longest continuous chain, and also use this as the longest continuous chain, and see if we get the same name, right? Now in this case, I'll start numbering my carbon. I'll then say my longest chain. In fact, before numbering, my longest chain here has 3 carbons, right? And they're all single bonds. It means now my base name will build up to be a propane, because prop again means 3, right? It will build up to be a propane, right? But now we need to number the longest chain. Now the carbons, we need to number them. Now when we number them, we're going to number them such that the branched chain or the functional group, if it's present, it is on the closest side, is on the closest number that we're counting. So for example, if I count from here, if I say this is carbon 1, this is carbon 2, and this is carbon 3, you can see that the branched chain here, right, which is an ethyl group, is closest from this side. But even if I count from here to here, it is still closer to, we get the 2 here. So this is a very simple organic compound that is not complex, right? So I'll number them from left to right. 1, 2, 3. I want you to also try numbering them the other way around, right? And see if you get the same name. Or if you take this as your main chain, I want you to also then you'll number them 1, 2, 3 in that case, and see if you get the same name, right? Now at this stage, now I'll then say on carbon 2 we have an ethyl group. No, it's not an ethyl, it's a methyl group, right? This is a methyl group. So on this carbon 2 here, right? So on carbon 2 we have a methyl group, right? So this means when we combine our name now, the full name would be a 2-methyl propane, right? So when we have letters and letters, we just combine them as one name, right? So we combine the base name to the name of the branch chain, right? But this gives us the position to say where it's located. So this is 2.3.2. Remember, I'm continuing with my incorrect error of numbering. So this will be 2-methyl propane. And then they also want us to name the compound F. Now with the compound F, we're going to firstly look at our functional group here. We can see that again we have an alkane, so it means our name should end with AEN, right? Because there's only single bonds. The functional group is an alkane in this case, right? Now we're going to identify the longest chain here. Now the longest chain, we can see that if I count these carbons from here to say 1, 2, 3, 4, 5, right? I have 5 carbons when I go down here, right? But if I count here 1, 2, 3, 4, 5, 6, right? Then I have 6 carbons if I go this side here, right? So just to make my point, I'm going to say if I come here, I have 5 carbons. If I count going straight like that, I have 6 carbons, right? Then another way in which we remember when we count, we also count the branch chain. The longest chain can be also branched, right? That's why I'm looking at all these possibilities. Now the other way to count this, I can say we have 1, 2, 3, 4, 5. So if I go this route, I'll also have 5 carbons. Now when you compare this path and this path and this path here, which one is the longest? Obviously the one with 6 carbons will be the longest, right? So that means we have identified our longest chain here. So our longest chain would indeed be this one here. So that's what we're going to use as the longest chain for naming the base name, right? Now we can see that we have 1, 2, 3, 4, 6 carbons there. So this means will be a hexane, right? Because the prefix to complete our base name for carbon starter 6 is hexane, right? So this means I'll have a hexane, right? Now at this stage I'll then look at my numbering of the longest chain. We're going to put numbers on the longest chain. Are we numbering from this side going there, from left to right, or are we numbering from this side? Now in order to know that, we always we start numbering from the side that is closest to the branched chain or closest to the functional group, right? So we can see here that our branch chain are actually here and here. Right? So if I count from this side, I say 1, 2, 3, right? The branch chain is on carbon 3. If I count from this side, 1, 2, 3, the branch chain is on carbon 3, right? So again, in this case, it doesn't matter from which side to start counting, right? And this already tells me that we'll have 2 different names that define the same compound. I'll do both those names so that we can explore them and look at them, right? So counting from this side and counting from this side will give us the same molecule, right? Now, so I'll start counting from this side first to say this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6, right? Now, when we name this, we are going to say we have a 3 on position 3, we have an ethyl. Our branch chain here, an alkyne that we have here is an ethyl because it has 2 carbons, right? So that should be an ethyl, right? But also when we come to carbon 4, we're going to have 4 methyl, right? Our alkyl group here, a branch chain here, is 1 carbon, right? We only have one carbon, so that is a methyl. Now we're going to combine this to form the entire name, right? We're going to combine this and that with our base name. Remember, this is our base name, to then find the overall name of our molecule, right? Now, the rule says that if we have two different branched groups, right, we name them alphabetically. So now if you check here, the E comes before the M, right? So I'm going to start my name with 3 ethyl, right? Because the E comes before the M alphabetically, right? Now this would be, the answer here would be 2.3.3. It will be 3 ethyl, and then we put the dash again there, and then we're going to have 4 methyl. And this has a base name of hexane. So that is 3 ethyl 4 methyl hexane, right? Now remember I said to you that in this case we are allowed to actually number our long chain from either side, because we notice that our branch chain are on the same position of 3. So even if I number from this side 1, 2, 3, 4, 5, and 6, I should get a different name, but that defines the same compound, right? We'll have 2 different names, but they define the same compound. Now in this case we will then have 1, 2, 3. Do you see then now this here will change into a 3 instead, right? Because our methyl is on carbon 3 when we number from right to left, right? And this one here will then also change into a 4, because now it's on carbon 4. 1, 2, 3, it's on carbon 4. And again, we number them alphabetically. We'll start with this, followed by that mixed with our base name, right? So this now means our name. So another name that we can have would be a 4 ethyl 3 methyl hexane. Now both these names are correct, right? They'll guarantee you the 2 marks there, right? Because if you take this and try to redraw it, and you take this and try to redraw it, you'll get the same structure. You'll get the same structural compound, right? So all this naming is with 2 marks, meaning you should spend 2 minutes naming this and applying your rules, right? They give you 2 marks for each one of those, right? I hope this refreshes the rules, right? And some of the techniques that you need to remember. Right now we're going to go to 2.5, right? In 2.5 they say write down the structural formula of compound C, right? Where is compound C? So compound C, they've given us a name here, 4 ethyl 2 dimethyl heptane, right? So the first thing that we'll do in order to write the structural formula really is to identify the fact that our base name is a heptane, meaning we have 7 carbons, right? So we'll start by doing that. So my numbering here, we are on 2.5. We are on 2.5 and we are answering 2.4.1. Again, here I see the numbering is incorrect, so we'll keep it as it is, right? So I'm saying my main chain has 7 carbons. So this is 1, 2, 3, 4, 5, 6, and 7 there, right? Then we are saying here that at carbon position 4, right, when we're at position 4 we have an ethyl group, right? So we have an ethyl group. So when we are at position 4 we have an ethyl group. So this means this is 1, 2, 3, 4. I'm going to number from left to right, right? So when we are here we have an ethyl group, we attach an ethyl group here. So this means I'm going to have H2, maybe let me do this, CH3, right? And we're also saying here that at carbon 2, right, when we are on carbon 2, right, we have a methyl group, but now di would mean 2. We have 2 of them. That's why actually we have 2 and 2, because the other one is on the other side and the other one is at the other side, right? So we have a methyl group. This is carbon 2. So when we get to carbon 2 here, right, we're going to have, right, so this 2 says this is the first 2, right, and this is the second 2. That's why it's di. They're both of them, right? And I think we covered everything, because we talked about this and talked about this being attached to our main longest chain. What's left here really is for us to then now put the hydrogens, right? What I can do here is that I can say here, no, what did I do? I can say here that I can say here that I have H3, because remember that this carbon here should have 3 bonds, should have a total of 4 bonds, and already I have 1 here. So if I add 3 hydrogens, I'm going to have a total of 4, right? And in the body there, we just add hydrogens, because then I'm going to have 1, 2, 3, 4 bonds, right? And we continue doing that for all of the carbons, right? And this will be an H3 there, right? This is how our molecule will look like. It is also possible for you to start counting from this side to say this is 1, this is 2, this is 3, this is 4, this is 5, 6, and a 7. Now it means now when we say 1, 2, 3, right, that's where you're going to have no 1, 2, the second carbon, that's where you're going to have this. So this can be this side, and when you say 4, this can be this side here, right? No, it will be on this part here, right? It is still the same molecule, because the name will be the same even if the structures, they look different, right? I hope that makes sense. Now we'll then move to, so here I just want to talk about marking. The first one is worth 3 marks and the other one is 2 marks. Now, no, we only have done one. So here the 3 marks will come from the fact that you identified this and the longest chain, right? So now we're going to also do a structural formula for E as well, right? So this is 2, this is 2.4.2. So let's look at compound E, right? So our compound E, you can see that we have 3 carbons, 1, 2, 3 carbons, right? So we're going to have 1, 2, 3 carbons there, right? And this one is attached to 3 hydrogens. So this means I'm going to have an H here and an H here, right? And this one is only attached to 1 hydrogen, right? So this means here I'm going to have a bond like that, right? But here we have a double bond, right? We have a double bond in them. The double bond should then allow us to have 2 more bonds that we're going to have there, right? Because already we have 1, 2, 3, 4 bonds in total, right? So here I see we have a typo here. So this should be 2 bonds, because we can't have 3 hydrogens, right? It should be 2 hydrogens bonded to carbon, right? So now that's our molecule. Now the other thing that takes place here is that we have an H2O. We have an H2O. You have to note that this H2O is not bonded. It's actually added, right? As I said when we were interpreting the problem, that it can be added as a reactant, meaning these two are reactants forming something else, or it could be that this is a product. There's something else that we started with forming these two. In either way, this is released as water. It will come out as a gas, right? So this is not a bond here. So our mark, the 2 marks here for this question, will emanate from you being able to break this down, right? Now we are done with that question. We then jump into the last part of the question that says to us that the compound B undergoes a reaction in the presence of a strong acid, the sulfuric acid here. So they use a sulfuric acid as a catalyst to form compound E. Right? So what are we saying here? We're saying we have compound B, which is this one here. I'm going to just put it down here to look at this reaction, right? So we are here now. We're saying here we have the CH3, CH2, and an alcohol there, right? We say this undergoes a reaction, right? It undergoes a reaction. So that means it will be broken down, right, into atoms and rearranged to form new atoms. But now here they say in the presence of an acid. So we have an acid here, a strong acid, right, which acts as a catalyst. It's not just an acid, but is a catalyst. All right. And obviously this type of reaction will need some form of heat, right, in order to run our reaction. Now we say here we get, let me confirm if I've written B correctly, CH3, CH2, CH2, and OH, yes. Then we say this forms this molecule here, right, which is given by CH3, CH, and a double bond here. So this means we're going to have C2. Remember, I've rectified this mistake here to say this is a 2, right? But also we have water here, right? That's been released, right? Again, what I was explaining here comes into play here to say this then means it's a product, right? So what's happening in this reaction when we look at it? We are decomposing, we are breaking this molecule down and rearranging it so that we form this molecule here, right? I can see that this is a propene because I have 3 carbons, right, and a double bond. So we're forming a propene and we're also forming water. So we're releasing water here as a gas in this reaction because there's heat, right? So the temperature will be high, it will be released as a gas. It will be in a gaseous state, our hydrogen, right? Our water, not hydrogen, our H2O. Right? So what basically have we done here? We have actually eliminated the water through the alcohol. We have taken some hydrogen here, formed water, and we are eliminating that water and releasing it, right? Thereby leaving this guy here being dehydrated without a water molecule, without a hydroxide molecule, the alcohol, right? So there's an elimination reaction, right? And more specifically, it's a dehydration reaction. We're dehydrating this molecule to be this molecule here without a hydroxide, right? Without water, and the water is being released, right? I hope that makes sense, right? This is what is happening in this reaction if I'm interpreting this reaction, right? So now let's see if we can answer the questions now. They say here, write down the type of reaction that takes place. I mean, this should come naturally from the fact that we already have seen the answer when we're breaking down or trying to understand the reaction itself, right? So this is a dehydration reaction. Please note that it is correct to say there's an elimination reaction, but be specific to say which type of elimination reaction this is, because if you write elimination reaction, it won't guarantee you a full mark. They'll penalize you. You have to be specific. Remember, there are different types of elimination reactions, right? So the last question here says, explain why compounds A and D are regarded as isomers. Let's look at A and D quickly. So when you look at A and D, right, we can see here that I have 1, 2, 3, 4 carbons, 1, 2, 3, and 4 carbons, right? But these carbons are arranged or are bonded differently. This is bonded along a straight line here. This is bonded such that we have a branched chain there, right? So that's why they are isomers, right? So in your answer here, you will then come and say compound A and compound D have the same number of carbon and hydrogen atoms. And this is very important because if you count also your carbons, you'll see that they're the same. 1, 2, 3, your hydrogens, I mean, 4, 5, 6, 7, 8, 9, 10, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So the number of carbons and hydrogens is the same, right? So we're saying that, yeah, but also now here, these atoms are arranged differently. They are positioned differently on the two molecules, on each compound. So let me see what I'm saying here. Let me navigate this and actually it makes sense, because I'm writing while explaining as well. We're saying compound A and B have the same number of carbon and hydrogen atoms, but these atoms are arranged differently, right? In each compound. That is the end of question 2 with 8 marks. So here they'll give you 3 marks for motivating your answer.